It's now time to meet one of the most important acronyms in the software development and architecture world, the SOLID. This acronym, coined by Bob Martin in the year 2000, represents 5 code design principles that, when implemented, make the code easy to understand, flexible, and maintainable. SOLID stands for Single Responsibility Principle, Open-Closed Principle, Liskov Substitution Principle, Interface Segregation Principle, and Dependency Inversion Principle. As we will see in a minute, all these principles are actually quite common sense, and you won't find any huge surprises here. However, we sometimes tend to forget the obvious, and it's good to have a solid reminder, see what I did here, to make sure we will still implementing them. So let's dive into these 5 principles. The Single Responsibility Principle states something quite simple. Each class, module, or even method should have one and only one responsibility, or in other words, a single well-defined functionality, and this functionality should be fully encapsulated within this class or module. Let's look at an example. Let's say we have a system that logs all its activity. Now, when writing to the log, there are 2 main questions that should be answered. First, what should be written, including the content of the log message and its format, which is usually JSON or XML. And second, where should it be written? Log records are usually sent to a file, a database, an event log, etc. And this should be determined and handled as part of the logging process. The Single Responsibility Principle states that these 2 questions should be answered by 2 separate classes. One is responsible for composing the message, and the other will handle the actual writing. So, instead of a single method that performs the 2 tasks, we will have 2 classes, each performs those tasks separately. The reason behind the Single Responsibility Principle is that when a change is required, it will affect only a well-defined code module, and we won't need to look for other obscure places in the code that might be affected by the change. This encapsulation will make our code very easy to maintain and quite flexible. Next, the Open-Closed Principle. The Open-Closed Principle states that a software entity should be open for extension but closed for modification. What this means is that in order to change behavior of a software entity, for example class, we won't need to modify its code and then recompile and redeploy it, but we will have means to extend its functionality without touching the code. This principle is closely related to the extensibility quality attribute we talked about in the previous section. There are multiple ways to implement this principle. The most common of them is the inheritance capability in object-oriented languages. Either inheriting a concrete class or an abstract class, we achieve the same goal, extending functionality without modifying the code. Of course, other types of extensions, such as plugins, are also widely used and fulfill the open-closed principle. The reason behind this principle is quite clear. We want our code to be as flexible as possible and enable us to make changes quickly without modifying and compiling existing code. The next principle is the Liskov Substitution Principle. This principle might sound a bit more complex than the other principles, but don't worry, we will explain it. The principle states that if S is a subtype of T, then objects of type T may be replaced with objects of type S without altering any of the desired properties of the program. On first look, this might look similar to polymorphism definition in object-oriented languages. Remember that polymorphism basically states that type can be replaced by its subtype without breaking the code. But there is a fundamental difference between the two. The Liskov substitution principle does not talk about coding or compiling, but on something called behavioral subtyping. Let's explain it through an example. Say we have a code that needs to send mail. The code calls a class named MailSender and calls its send method, which, as you probably guessed, sends the mail. A few months later, the developers come up with a better mail sending class called Advanced Sender, which inherits from the original MailSender. The developers want to substitute MailSender with Advanced Sender in their code. The Liskov substitution principle says that when doing this substitution, the behavior of the send method should not be changed. If the original method only sent the mail, the new one should do the same. There should be no new functionality that is unexpected by the calling code, such as throwing new exceptions as a result of the substitutions. For example, if the new method not only sends the mail, but also automatically sends a copy of the mail to a central archive inbox, that will break the principle and should be avoided, since it breaks the behavior of the original type. The reason behind this principle is to avoid hidden behaviors that were not intended by the calling code, thus making the code much more difficult to debug and to maintain. The next principle is the interface segregation principle. This principle states that many client-specific interfaces are better than one general-purpose interface. Again, let's look at an example. Let's say we have a class that handles data processing. The class begins small with two methods: read data and validate data. An interface named iDataProcessor was created that defines those two methods. While working with the class, additional methods were added to it that handle more tasks, such as decode data, encode data, and send data to external systems. These methods were added to the interface too. Now, what we've got? A bloated interface with 5 methods that must be implemented by a single class. Remember the single responsibility principle? If you take a look at the class, you can see clearly that the class breaks this principle. It now handles 3 tasks: handling data, decoding and encoding it, and sending it. The developers saw it too and decided to split the class to 3 separate classes. However, they now have a problem. The interface forces them to implement all those methods using a single class. The interface segregation principle says we better create multiple thin and well-defined interfaces than a single general-purpose one. So in our case, instead of a single interface with 5 methods, we would be better off with 3 interfaces with 1 or 2 methods. This way, our code can be modular and flexible and keep the single responsibility principle. The last principle is one we have already talked about in the previous lecture, the dependency inversion principle, also called dependency injection. If you don't remember, head back to the previous lecture and watch it again. And that's all about Solid acronym. Again, the principles here are all common sense, but it's a good reminder and will help you keep the code clear, flexible, and easy to maintain.